I recently invited three of the biggest names in UK heat pump installs, Octopus Energy, E.On Next, and Heat Geek, to conduct a survey in my home, but ultimately I chose Heat Geek via their elite installer Mark from Green Home Heating to go ahead with their brand new Zero Disrupt install. Currently in beta testing, these installs aim to deliver you a heat pump with zero disruption at an affordable price and without compromising efficiency. But what exactly did I get for my £2,150 final install price? And does a Zero Disrupt install actually work in real life? Or am I just a guinea pig? In this video, I'm taking you behind the scenes of my Heat Geek Zero Disrupt install, showing you everything I had fitted, and sharing my first impressions. If you're curious how one of the most innovative players in the heat pump industry is shaking things up, you'll want to stick around. Welcome back to the channel, my name's Shan. If you've followed my channel for a while, you'll know we are a family of 6 living in a 5-bedroom detached house built in 1999 with a floor space of around 179 meters squared and an EPC B rating in the northeast of England. It had a 26-year-old Poston Suprema 70 non-condensing boiler which had an efficiency of around 76%. We have 2 solar arrays, one installed in 2015 and one in 2022, an 8.2 kilowatt-hour battery and an electric vehicle. And I'd been debating installing a heat pump to complete our all-electric move and get rid of the gas for good for some time now. In my first video in this heat pump series, I estimated I could save £732.84 per year by installing a heat pump in addition to my other green tech compared to running my inefficient gas boiler. With this in mind, I compared 3 heat pump install surveys from Octopus Energy, E.On Next, and Heat Geek. Heat Geek came out on top owing to their more realistic heat loss calculation, readiness to work with my existing 300-litre hot water tank, which is only a couple of years old, guaranteed overall system efficiency of 3.43 for a fantastic 5 years. That's both hot water and central heating rather than the SCOT that just relates to central heating. And of course that final price of £2,150. One thing you might notice is that not one single radiator change was proposed for our install. Instead of just following a one-size-fits-all checklist, Heat Geek used their back-tested algorithms to model exactly how my home would perform with our existing radiators, taking real-world usage data and thermal dynamics into account from their hundreds of installs. I had the reassurance that comes from working with a Heat Geek Elite installer who really knows their stuff. Plus that 5-year efficiency guarantee gave me the confidence to trust their process. So if the system doesn't hit that performance target, they'll make it right. For me, it's smarter than a generic install design and saves a lot of unnecessary swaps or upgrades, which is better for the planet and my wallet. Just to say, this is not a sponsored video by any of the companies I've mentioned, but rather I'm sharing my journey into the world of heat pumps, and all the views expressed in this video are my own. If you want to join me on this journey so you can benefit from learning from my success and regrets, please subscribe to the channel for free so you can enjoy future videos just like this one. I'm also a homeowner, not a heat pump technician, so whilst I've made every effort to make sure all the technical stuff in this video is correct, if I do get something wrong, I'm still learning. Feel free to let me know in the comments below so we can all learn from it. Green Home Heating had an installation slot just less than 2 weeks after my heat pump survey, and after signing on the dotted line, we had a Zero Disrupt system commissioned on the 1st of July. I'm going to start with the main attraction, my new heat pump. Following our heat pump survey, it was suggested that we install a Valent 7 kW Aerotherm Plus, which would meet the 6.7 kW heat loss requirement of our house. I've heard generally great things about Valent heat pumps, so I was pleased with this recommendation. It also comes with a massive 7-year warranty, provided it's installed by a Valent approved installer such as Heat Geeks, and annual servicing requirements are met. Mark and I were in complete agreement that the best location for the heat pump is at the side of my property, with no real solid obstructions either side of it, and a straight run up the side of the house for the pipes and into the loft where my hot water cylinder sits, behind this wall. The decibel rating on this heat pump is 54, and with its location calculated to be around 10 meters from my neighboring property and being separated by these bushes and a fence, there should be absolutely no issues here. Mark suggested 2 main options for its mounting, either on feet which would protrude a bit onto the pathway or on a wall bracket. although he did advise me that occasionally some owners have noticed some vibration internally from the heat pump when in use. We chose to go down the bracket option, which we thought looked neater. And as the wall directly behind this backs into our kitchen rather than the bedroom, we didn't think it would be an issue. And having been up during a hot water cycle, there is barely an audible hum through the wall if you listen closely in the kitchen. Much quieter than when our gas boiler used to kick into action. But what about the pipes? Obviously, these needed to be covered for several reasons, including preventing heat loss to maintain efficiency, safeguard against the weather, and leave a tidy professional finish. We again had two popular options here, using external trunking or primary pro insulation. We saw benefits of both of these options, but in the end went for the primary pro insulation. As for Mark's suggestion and my further research, it is known to provide excellent thermal insulation and therefore improve efficiency. I'd also seen images from Mark's previous jobs and the finish was excellent. But could we have both? Primary pro insulation in trunking. Whilst this is an option, after researching this further and chatting it through with Mark, I decided against it. Due to the potential for trapped moisture, the trunking potentially compressing the primary pro, therefore reducing its thermal efficiency, and finally the additional cost. Super important point here. When it comes to running the heat pump pipes through your external wall, it's absolutely vital your installer keeps those pipes wrapped in the primary pro. Why is this so important? Well, any section of pipe that passes through bare brick, if left uninsulated, becomes a prime spot for heat loss. Even a short uninsulated stretch effectively acts like a thermal bridge, allowing heat to escape directly into the wall, which means wasted energy and a less efficient system overall, making a real difference to your energy bills and carbon footprint. But it's not just about efficiency. The area inside a wall is a cold, sometimes damp environment. Without proper insulation like primary pro, moisture can condense on the exposed pipes, which over time risks erosion and even potential freezing during colder months. So make sure your installer, like mine, sees that this happens. You'll notice below the heat pump, Green Home Heating fitted a soakaway, which serves to manage the moisture or condensate that naturally forms during the heat pump's operation. They dug down to around 600mm, backfilled it with larger stones at the bottom so there are gaps for the condensate to drain away, smaller stones at the top, and at the surface, the pebbles that were already there to make it blend in as much as possible. This is important as without it, condensate could pour under or near the heat pump, causing damage to the unit or the surrounding structure, slippery surfaces, or freezing issues in cold weather. I really like the way it integrates into the gravel area we had here before, and unless you're specifically looking under the heat pump, you don't really notice this. Finally, for changes directly related to the heat pump, the old non-condensing boiler was removed. We had some spare matching bricks, and one of Mark's teams expertly patched up the hole left by the flue. So well, in fact, you'd never known it was ever there. Right, let's move on to the hot water cylinder, as this is where other installers wanted big changes. Okay, so I'm not in my loft as it's sweltering in there, and not that well lit. Both Octopus and E.On wanted to rip out my nearly new 300-litre hot water cylinder, mainly because its internal coil is smaller than the ideal for a heat pump. Traditionally, larger coils let the heat pump work more efficiently, but swapping cylinders is costly and messy. After our Heat Geek Elite installer Mark input the details of our existing hot water cylinder, including its capacity, coil size, and age into the Heat Geek Zero Disrupt algorithm, it concluded that it should work just fine. I was really pleased about this from a sustainability and cost point of view. It's also worth noting that the Heat Geek Zero Disrupt algorithm worked out the efficiency of my hot water and heating. And Heat Geek don't just guarantee a minimum overall efficiency. Their guarantee also covers if we run into any issues with not having enough hot water or space heating, which is really reassuring to know. There is also a contingency in the Heat Geek design to increase the cylinder temperature, without it significantly affecting the efficiency. But from what I understand, they've not had to utilize this strategy yet. Mark added if we were to run into any issues in the future, a plate heat exchanger can be added to boost hot water heating. And this is actually what my original cylinder installer meant by can be modified in the future if needed for a heat pump. Adding a plate heat exchanger to a heat pump system that's struggling with a small cylinder coil would allow for much faster, more efficient hot water production and resolves any issues of slow heating and reduced efficiency, all without replacing the cylinder itself. For our Heat Geek Zero Disrupt install, Mark's team connected the new flow pipe from the heat pump onto the existing valves. I have new 2-port valves that have been reconfigured to operate with the Valen controls to open and close automatically. hot water takes priority. So when there's hot water demand, the heating system is shut off, allowing the heat pump to achieve a higher temperature to satisfy the hot water demand. Once the hot water tank is up to temperature, the valves switch back. The hot water circuit closes and the heating circuit reopens. The system returns to an efficient low temperature heating mode, adjusting itself based on outdoor conditions. That's where the weather compensation comes in, which I'll come on to later, so your home stays comfortable with minimum energy use. But has it worked as it is, without the need for a plate heat exchanger? It's been brilliant, and a massive shout out to the Green Home Heating team. They worked tirelessly on one of the hottest days of the year in my loft and were professional, courteous, and committed throughout. I'm currently running the hot water cycle overnight when the off-peak electricity costs me just 6.7p per kilowatt hour between midnight and 7 AM. Even though my hot water cylinder only loses 2 degrees every 24 hours, I've set the hot water heating right up until the end of my cheap electricity slot, which coincides with when we'll need to use the hot water for showers in the morning, which will ensure any heat loss is minimized. At install, our hot water tank settings were optimized to heat to 50 degrees by our Heat Geek Elite installer. But not wanting to run out of hot water, I bumped this up to 65 degrees to ensure it lasts us the whole day. That must have tanked the efficiency, right? Well, compared to the coefficient of performance, or COP, of 2.5 I predicted in my first video to work out my estimated savings, I was actually getting a COP of around 3.2 to 3.4, and we had more than enough hot water to last the whole day. So I needn't have worried. We actually had enough hot water for the whole family. That's 5 showers and 1 bath in 24 hours off that one off-peak heating cycle. So I nudged it back down gradually to 50 degrees and have been achieving a COP of around 4 since doing so. In fact, even with my tinkering since install on the 1st of July, we've averaged a COP of 3.7 for the month of July and consumed 101.6 kilowatt hours of electricity. At 6.7p per kilowatt hour, that's £6.81 for 31 days of hot water, just 22p per day. Compare that to the £1.08 per day with gas at the current price cap of 6.33p per kilowatt hour. That's a saving of 86 pence per day on hot water alone. If you like the look of the E.ON Next Drive tariff, which whilst recording this video has changed to 7.5p per kilowatt hour off peak for 6 hours, and plan to sign up, then please consider using the channel's referral link in the video description box below to split £100 of E.ON Energy account credit between you and the channel. Thank you in advance if you do sign up via a referral link. It really does help keep the channel going. This just goes to show, with good system design and careful commissioning from Heat Geek, existing cylinders can be integrated effectively without needing that default upgrade. This meant significantly less disruption and mess during our install, which was a big win for us. Don't forget, Octopus suggested we could move our washing machine and tumble dryer to the first floor airing cupboard and stick our cylinder in the utility room. Imagine us coming to sell our house in the future and explaining the rationale for that move. Over winter, I can keep my hot water heating programmed for the off-peak slot, as when the hot water set temperature has been reached, the system will go straight back into heating mode. This means I won't need to worry about changing any settings here, which is one less thing to think about given our busy family life. The only time I might need to change it is if it's taking too long for our water to heat to the set temperature, resulting in our house feeling a bit chilly. Since hot water heating isn't particularly efficient compared to space heating, the last thing I want is for the system to keep cycling back and forth between water and space heating because the cylinder temperature drops slightly. This is where hysteresis comes in. Hysteresis is essentially a smart built-in delay or buffer in the hot water system's controls that prevents it from constantly turning on and off too quickly. For example, our hot water tank has a target temperature of 50 degrees Celsius. Instead of the heat pump kicking in as soon as that temperature drops a tiny bit below 50 degrees, hysteresis means it waits until the temperature falls to a set point. The hysteresis set to 5 Kelvin via the SensoCOMFORT controller would mean the water temperature would need to fall to 45 degrees before it starts heating again to 50 degrees. But why does this matter? Because it stops the heat pump from short cycling, turning on and off too quickly, which wastes energy and causes unnecessary wear and tear on the system. With hysteresis, the heat pump runs steady, efficient heating cycles that keeps your hot water comfortably within a set range instead of constantly fluctuating. It's worth noting that the current temperature displayed here on the app is linked to the probe at the lower third of the tank. So even if it reads 20 degrees Celsius, you'll still have plenty of hot water higher up in the cylinder. Winter will more than likely see a reduction in the COP achieved for water heating, since heat pump COP declines as outside temperatures fall. I'll of course monitor its efficiency closely and report back when initial performance and hot water delivery have smashed my expectations. But what about Legionella, I hear you cry? Legionnaire's disease is a severe form of pneumonia caused by Legionella bacteria and is typically contracted by inhaling contaminated water droplets. When it comes to heating hot water in our homes, a lot of advice there says you should always keep it at 60 degrees or above to prevent Legionella. However, for most UK homes, especially with heat pumps, this can be unnecessary, less efficient, and potentially even increasing the risk of scalding, especially if you have young kids like we do. If you use most of the hot water in your cylinder in a family home, setting your default tank temperature to 50 degrees and relying on a weekly or after holiday hot water cycle at 60 degrees is both energy smart and safe for most people. Our Valent kit has a default Legionella cycle, which was set by my installer to come on in the early hours of Saturday morning during our off-peak electricity rates, raising the cylinder temperature above 60 degrees to help kill any Legionella bacteria. Having a higher hot water temperature works quite well on this day, as we tend to use more hot water at the weekend when the kids have showers after football. And you can clearly see the days when the Legionella cycle was scheduled to come on, as it does use a bit more energy as expected. Of course, always factor in the specific needs in your home. Elderly or medically vulnerable people, or rare cases where you hardly use hot water, may need a tailored risk assessment. Adam from Heat Geek explains this beautifully here, and I'll drop a link to this video in the description box below. A couple of people in my last video commented that I had to replace my hot water cylinder to qualify for the boiler upgrade scheme or bus grant. According to the official bus installer guidance from Ofgem, page 25, an eligible plant's ancillary equipment does not need to be new and can be retained from the previous fossil fuel or electric heating system. More detail is given at paragraph 3.55 and table 2. There is no strict rule in the bus that mandates replacing the hot water cylinder as long as it works effectively with the new heat pump system and meets the minimum scheme standards. Just as a side note, if you do need to replace your hot water tank, when we had our old 180-litre cylinder taken out 2 years ago, I took it along to a local scrapyard and managed to bag around £150 for it, so it's well worth doing. Lastly then, the Valent SensoCOMFORT is a smart, intuitive heating control which is designed to be the command center for our heating and hot water system. One of the key features is its weather compensation technology, paired with an outdoor sensor, usually installed on the north or northwest facing wall, that constantly monitors the outside temperature and automatically adjusts the heat pump's flow temperature to keep our home comfortably warm, without wasting energy. The idea is that when it's colder, the system will automatically increase the flow temperature to our heating system, warming our radiators more. Conversely, when the outside temperature rises, it lowers the flow temperature to save energy, reduce carbon emissions, avoid overheating our rooms, and reduce our energy bills. A heat pump works a lot like a car's cruise control. Rather than turning on and off in big bursts like a traditional boiler, it continuously adjusts its output to just the right amount needed to balance any heat loss from my home to the outdoors. The goal isn't to race ahead or lag behind, but to find that Goldilocks zone, keeping your home just right all the time, with minimal effort and maximum efficiency. Just like cruise control gives you a smoother, more economical drive, this approach keeps your home at the perfect temperature, avoids waste, and helps your heat pump last longer. Well, that's the plan anyway. It's currently a pretty decent British summer, so there's been absolutely no need to have the heating on apart from during the commission test. But as we head into winter, I'll be sharing how I have my heat pump set to achieve its maximal efficiency. And if you want to get notified when that video lands, you know what to do. The controller has a touchscreen display with simple navigation, allowing you to set your desired room temperatures, create heating schedules for weekdays, weekends, or 24-hour periods. For more flexibility, I can remotely manage my heating and hot water from anywhere using the Valent app on my phone or tablet. The app lets me create and customize detailed heating schedules, setting different temperatures for weekdays, weekends, or particular times of day. This flexibility means our heating can match our lifestyle perfectly. It also gives me access to an energy usage dashboard, where I can track my heat pump's consumption daily, weekly, monthly, and yearly. This data will help me understand my heat pump's energy consumption patterns, spot saving opportunities, and verify how my time of use tariffs affect my bills. For further and more accurate consumption data, I plan to fit a dedicated energy monitor. Finally, the app supports remote diagnostics and software updates. I've also given my consent for my installer to be able to remotely monitor my system, to troubleshoot or optimize my system remotely if needed, which should reduce in-person callouts and downtime. You may have noticed that the SensoCOMFORT device has replaced the tado smart thermostat that was fitted on this wall near our entrance. Tado and other third-party smart thermostats work really well with conventional or combi gas boilers, allowing you to control on-off cycles and set detailed schedules room by room. As I've already mentioned, heat pumps are most efficient when they operate continuously at low temperatures, modulating their output to match heat loss of the house instead of frequently turning on and off like a boiler. It makes sense then, when the heat pump and its controls were installed and commissioned, our tado devices were removed, both for technical compatibility and to keep the system running as efficiently and reliably as possible. I could have left my smart TRVs in place to monitor each room's temperature, but I suspect they'll be better used to reduce unnecessary gas consumption in someone else's house, and that's why I've listed them for sale. If you're not quite ready for a heat pump but want to optimize your energy use, definitely check out my tado kit, complete with wireless smart thermostat starter kit V3 Plus with hot water control, internet bridge, and a massive 11 smart TRVs. I've dropped the link in the video description if you want to check it out. So I've had my heat pump in for a little over a month now. What are my first impressions? I have to say I'm absolutely blown away by how well the hot water heating is working with my existing cylinder. As you'll know, I was a bit concerned given that two massive energy companies recommended replacing it, that we might not have enough hot water and it wouldn't be very efficient. But so far it's performing brilliantly. Plenty of hot water, efficient operation, and no need for any expensive cylinder upgrades and all the mess that goes with it. I know it's early days, but this promising start makes me really intrigued to how the heating side of things will fare. I'm looking forward to seeing how the heat pump handles space heating over the coming months, especially through the colder seasons. It'll be fascinating to track the real savings compared to my old inefficient gas boiler and see how much impact this makes on my energy bills and carbon footprint. As we approach winter, I'll be sharing with you how I configure my heat pump's heating controls and fine-tune its efficiency along the way. Make sure you're subscribed so you don't miss out on these and more great videos. Thanks for watching, and I'll see you in the next one.